So one of the major functions of the charge controller is to what? Is to regulate. A charge controller is a device that regulates your power in what? Voltage and current. Are we there? Remember, the solar panel is bringing in power in forms of current and voltage. So in order for you not to overcharge your battery, you have to introduce a charge controller. Are we there? So this charge controller has in all power it accommodates, both in the PV voltage and what? The battery voltage. Remember, it's a device that works between the panel and the battery. So assuming you have two solar panels here, right? So now you will now have your what? Your charge controller. Here you will have what? This will be plus, this will be minus. Is that not so? So you run your panel to this charge controller, then you run your panel to this charge controller. Then from charge controller, you still run it to what? Your battery. Are we there? So the charge controller is that device, device that serves as a regulator between your panel, which is your panel, and what? Your battery. Are we together? Hello? So this is what? This is what? Your battery. So this is your charge controller. So when you connect your panel to the charge controller, you connect it to what? Your battery. But what you normally connect first is what? Your battery. Before you connect your panel. Are we together? The charge controller helps to see the level of your battery. Because if power is coming in from the panel, it keeps coming, right? Charge controller will help to see the level of your battery. If your battery is on this state, hello, everybody look up. Everybody look up. Here, this is your battery. Right? Here is 0%. Is that also? Here is what? 50%. Hello? So this place will give you 100%. Am I correct? So now, this is your battery. So now, this battery is rated 12 volts. Are we together? So if this battery is rated 12 volts, and from here, this is the lowest point, 0, the battery will keep charging to 100%, which is 12 volts. Now, this 12-volt battery can charge up to 13.5 volts, even up to 14 volts at what we call float charge. But ideally, fully charged battery is supposed to come up to 13.5 volts. The same battery can drain up to 11.5 volts before it will cut off. That is, the battery has finished. Hello? Now, the reason why I bring this illustration is, for this 12 volts, it might be that when the battery is 100% fully charged, you will have maybe 13.5 volts on this top here. Are you seeing me? Then, these are battery, these are charge controller connected on this point. Remember, when you connect this battery to the charge controller, it will be reading for you 12 volts. 12 volts. Let's start from the beginning. 12 volts. Now, you are done that part. When you send in your solar panel on it, hello, are we together? When you send your solar panel on it, the charge controller will see the level of your battery as at 12 volts. Power coming from your solar panel, it will know the power that is good to release at that particular time to the battery. There's a difference between the battery is 11 volts and when the battery is what? 12 volts. So the charge controller will be dropping an amount of current power on the battery, depending on the level of the battery. If the battery has come to this extent and its battery comes here, hello, let me say here might be 11.8 volts. It comes here, it will be 12 volts. When it's fully charged, it will now give us 13.5 volts. As when it's getting here, this controller might be charging it with maybe 3 amps. Hello. Then as the battery is coming up, it will now turn to 2 amps. Hello. Why? The controller is seeing the level of the battery, so it will not overcharge the battery, because overcharging battery can kill battery within a short period of time. So as the battery is coming up, the power coming from the solar panel is reducing through the help of the charge controller, so that it will stop sending excess power to the battery. Because the reason why we are charging this battery is to store our charges, which is the energy. So there will not be any point whereby your battery is fully charged and you still charging it. That means this guy no get use now. Are we together? So it is sending in, the battery is also coming up, and the power coming from the panel is reducing. So that is how the charge controller will begin to function, the work on it. See, the battery gets full, and when the battery is full, this charge controller will sense that the battery is full. It will cut it off. This charge controller is called PWM charge controller. What is the full meaning of PWM? PWM means pulse width modulation. That means this one can. What is the meaning of? If they say pulse? Can help me with the meaning of pulse? Not that pulse.
Pulse means like charge.
In this aspect, this charge controller, this pulse width modulation, even though the battery is full, it can still be dropping a little drop. It does not totally cut it off. Hello, we have another MPPT. Hello, we have another charge controller that is called MPPT. What is the full meaning of MPPT? What is the full meaning of MPPT? Multiple power point tracker. These are the two types of charge controller that we have. Hello, we have this one, we have MPPT. MPPT is the advanced level of this controller. These controllers can be used when you have 2 panel, 3 panel, 4 panel, maximum 6, depends. This PWM. This PWM is used in small installation, small size of solar system. MPPT can be used for bigger size of solar system, but it can accommodate more and have more features, more functionality than PWM. So PWM have its own way of working. Till today, people are still using it. MPPT have its other way of working. But if you need maximum output for your solar panel, MPPT is the best controller. Hello? Hello? I'm not disputing the fact that this one doesn't work, but if you need to harvest the best from your solar panel, when you want to use a controller, MPPT tends to give you that kind of work or that kind of output. Hello? So we can see that from here, this one is used to regulate, and this regulator, this charge controller, help us to prevent the battery and the panel, in the sense that it cut off the power so that the power cannot go back to flow back toward the panel. Hello. Number one, it regulates. Number two, it prevents overcharging. Hello. Number three, it prevents what?
Power returning to the
panel. It prevents discharge. Number one, regulate. Number two, prevent overcharge. And number three, what? Discharge. Hello. Hello. So you cannot just connect your panel to your battery direct. That battery will charge. But one of the problems at the back of it is that even when the battery is full, there is nothing there to tell you this battery is full. Or this thing, cut it off for me, I don't need it. The panel will keep charging because there is no device to regulate what is there. Hello. So you cannot undermine or overlook this charge controller as far as you are seeing it here. If not, you damage your battery within a period of time. Even human being you are seeing have expiry date. Is that not so? No matter we live, we will die one day. Even if you live 150 years, one day you will see die. Are we together? So all these devices, everything in this surface of this earth have expiring date and how the way they work. And most times, system dies early or faster when you overuse or overstress them. Because even you, if you subject yourself to much work or stress, you will see that you break down. Hello. So the same thing happens to this kind of system. That is why we have to know how to size them. Sizing come under design. Where they come sizing solar system comes under design. But you know the capacity of this controller, you will now know the maximum PV, which is panel voltage you will connect to so that it will not burn. Hello. Then this controller have the kind of battery you can connect to it. And such controller are rated in amps. Such controller are rated in what? Amps. Solar panel are rated in what? What? Why charge controller are rated in amps? Are we together? Because when you go to the market to buy a charge controller, you go to the person and say, I want to buy a charge controller. He will now ask you which capacity or which rating. You will say 40 amps. This one you are seeing is rated current. What are you seeing?
40 amps.
This one is 40 amps. Hello? Hello? Are we understanding something? So this one is rated 40 amps. Then how many PV you say? PV voltage is what? Maximum PV voltage is what? 50 volts. That means when they say maximum, who understand maximum? So maximum PV, what did I say PV is?
Solar panel.
PV is what? Your solar panel. So when they say maximum PV, they are not saying that maximum solar panel voltage. That means what is coming into this place should not be more than 50 volts. And you cannot see with your reasonable sense, you cannot see a solar panel of 50 volts. You will not come and connect it to that solar of 50 volts. Because if the solar panel produce more than 50 volts and this charge controller is not being in use at the same time, because if there is battery on it and you are using it at the same time or charging, the 50 volts might not have more effect on it because it's like it's coming in and it's going out. But when the battery is freed up and the sun now goes up and the panel is giving 55 volts, it might damage the controller. So it is wise to say the highest PV voltage to connect on this kind of controller is 45, if not 40. Always leave a gap, tolerance on any system you are working on. Apart from panel that you want to increase your power so that the battery will charge faster. When it comes to charge controller, let there be a tolerance. Let there be a space. When it comes to battery, you can size battery. You can size panel and battery to be bigger. But when it comes to what they are working with, you always size them too, so that everything will be within each other. Hello. When it comes to your inverter, if you have load of 1,000 watts, you can now say want to use inverter of maybe 2,000 watts or 2,500 watts. This one will give the inverter enough room. Now sometimes even when you on everything on it, the inverter will not be stressed out. And it gives you the privilege of you also adding more load on it depending on the type of load. It should not be as if you have 1,000 watt load, you will not go and buy inverter of 1.5 kVA. But when we begin to teach inverter, I will begin to tell you the real capacity of inverters. Not that they say inverter is 1 kVA. It's not 1 kVA. If you multiply power factor, it will give you 800 watts. Even the hybrid inverter say 1 kilowatt is not 1 kilowatt. And you cannot sublet load of 1 kilowatt to 1 kilowatt. Hello? Are we getting it? So that is how this system should be. This one I said they are rated in current. This one is 40 amps. It will not be wise on your side to connect panel that are producing 40 amps to this charge controller. Now I'm done with the issue of what? Voltage. This is the issue of current. Because believe it or not, your panel is bringing it both voltage and current. That makes it up what? The power. Voltage and current is like husband and wife. You can't separate the two from each other. If not, the system will not work. So when you are dealing with voltage, also work on your current. Are we together? So here you cannot connect 40. Assuming we have 4 panels, this panel will now have 4. Each of them is giving us 10 amps. And we say this 10 times 4 will give us 40 what amps. This guy in your presence, he go burn, he go smoke. If you have these 4 panels that are producing 10 amps each, the highest you can go is to what? Connect what? 3 to give you 30 amps. Hello? Even with the 30 amps, with other factors, we have losses in the system. Panel also give you the efficiency of panel. They give you 75% the real panel output, because as temperature increase on the panel, as sun comes, bring heat, there will be losses. Temperature increase and there will be losses. So those losses will remove some power from the system. So you cannot get 100% output from your solar panel. Despite that, you will still need to be on the safer side. Hello? So you cannot connect only three to give you what? 30 bigger wattage, bigger voltage, bigger current. So now the power consumption is depends on what? The wattage. This wattage 50 watts and this 190 watts are not the same voltage, are not the same what? Current. So what I'm trying to say now is for you to know that in so panel and so charge controller, they can work together where you have so voltage and what? Current. Now, if somebody goes to the market and buy this panel, and we are assuming this panel is 10 amps, somebody go to the market and buy 6, and he bought this one, he might not actually understand, because some of these clients, they will watch as we post videos, they will watch videos, people, even the sellers, they want to tell their guys this will work, just to sell markets. I understand. Once we are done, they will say, okay, don't worry, I have installers. You will not call your installer to come and install. At that point, when you come and see 6 of these panels, the reason why I'm saying that this panel is, what do we see? The VOC of this panel was what? Who remember the VOC of this panel? Eh? The VOC was, let's say 45. Let's forget the other decimal point. Let's say 45. Now they are telling us that maximum PV voltage, right? I'm giving people a clue now, okay? And now it's all right. Yeah. I'm giving people a clue now. This charge controller, maximum PV 50 volts, rated current 40 amps. Now this panel VOC open circuit voltage is 45 volts. Now we cannot connect more than one of this panel on this charge controller, but we can connect up to, this panel is giving us 10 and we connect up to 3, but we will not connect them in parallel. Parallel connection increase current, voltage remain the same. So in a bit of when you are connecting them in parallel, you are not increasing voltage. Your voltage value is within the range of this charge controller, but now you are increasing your current. Are we getting it? By connecting them in parallel. So 3 of this panel can go in to the charge controller and it will work perfectly. Are we together? So when you connect it to this charge controller, it will work well. But if you want to increase, or you will not think that your client that go and buy 6 panels of 10 amps each, right? This controller will not work. You advise that, because even if you want to connect 3, in parallel, 3 in what? Series, it will not see work. Why? Because whatever that makes you to do series, you are not say 45 plus 45. It will give you 90 what? That means this guy cannot take it. Hello? So most of the solutions they do with PWM charge controller are parallel connection from your solar panel. They are parallel. And if you see this kind of connection, you will see maximum 6 panels. Maybe small panels like this one, maximum 6 panels, because this one, if you are using this size, this one is about 5 amps. Then 6 times 5 give us 30. So even this one that is about 5 amps, the maximum we can connect on this is 6 of this type. That is the maximum. So if you see any panel like that, if you see any system, person install this controller, check the number of panels they install on that system. maximum 6 of the small panel. If it is big panel, maybe 3 or 2 or 4, depending. Hello. I said charge controller is rated in amps. We have 10 amps, we have 20 amps, we have 30. This one is 40. We have what? 50. We have 60. 60 is the maximum under this type of charge controller. 60 amp is the maximum. Hello. When it comes to PWM charge controller, we have it currently now up to 120 amps on MPPT. The maximum on MPPT is 120 amps. Though we still have 30 amps, 45 amps, 60 amps, 80 amps, 100 amps on MPPT. Then the maximum we have now is 120 amps. Hello? Are we together? Now, see, there is, they say, rated voltage. You are seeing, okay, rated voltage. How many are seeing? 12 volts slash. Rated voltage here, 12 volts slash 24 volts. So, hello? Another thing you will see on charge controller is what? The rated what? Voltage. Can you see the board? Can you see what I write? Hello? Rated voltage. They will now show you 12 volts slash 24 volts. This voltage I'm telling you is for battery voltage. Hello? Once you see, sometimes they might add for 24 slash 48 volts. Hello? What it means is that this charge controller can accommodate 48 volt battery system. Hello? Okay, now let's remove what? 48. Let's rely on 12 volt 24. That means this solar panel can do what? This charge controller can do what? Can work with 24 volt. 24 volt what? 24 volt what? Then our battery is 12 volt. One battery is 12 volt under lead acid battery. That battery used to see around all those tubular battery, normal gel battery. They are rated 12 volt. If you bring two together in series, it will give you 24 volts. That means if you have that kind of two battery connected together, this controller can still work in that 24 volts. If you even though you have one battery, this controller can work with it. Hello? Are we there? So whenever you see anything like this, whenever you see anything of this sort, you know that they are talking about your battery. Hello? So I've talked about rated current. Rated current is what? 40 amps. Then the last thing there is maximum PV voltage is what? 50 volts. Hello? I've explained this one. I've explained this one.